Hello, I am Juan-Juan, your Six Sigma instructor, and today we're going to talk about one of the most important tools of the root cause analysis, the fishbone.
Juan-Juan, before we start, can I ask you a question?
Sí.
Is Juan your first name or your last name?
Oh, that's simple. My first name is Juan, and my last name is the number 1.
So in reality, your name is Juan-Juan.
Is what I said. Juan. Anyhow, let's talk about fishbones. Welcome back. As a Six Sigma specialist, many times you need to perform investigations, either as part of a corrective action, a process improvement, a lean manufacturing, or any other Six Sigma project. There are several methodologies that you can follow, such as an AD, a DMAC, a PDCA, or a DOE, just to name a few. And something that all these methodologies have in common is that eventually you need to perform a root cause analysis. No, not this kind of root. A root cause analysis is a technique to find out the real cause of a problem. For example, what is the real cause of high scrap? What is the real reason of inefficiencies in a process? Or what is the real reason of process variation? Same as before, you can use different tools to perform the analysis, and two of the most useful are the 5 whys, which I will discuss in a different video, and the fishbone diagram, also known as the Ishikawa diagram.
Juan-Juan, what exactly is a fishbone diagram?
Oh, good question. Allow me to explain. Let me show you something interesting. The original name of the fishbone diagram is the cause and effect diagram, and it was created by Dr. Kaoru Ishikawa around 1949, and it was published on his 1981 book, What is Total Quality Control? The Japanese Way. This book was translated to English in 1985 by David Liu, and this is an original 1985 book, which, by the way, is book number 295 of Mr. G's personal collection. In Chapter 3, The Essence of Quality Control, Dr. Ishikawa presented the diagram, which, by the way, had only 5 branches for the possible causes of variation: material, machine, measurement, man, and method, the original 5 M's. Over time, a 6th branch was added to include the environment, and the names of the branches have changed to be more inclusive. But this is the original diagram. And this is a very cool quote from Dr. Ishikawa. The diagram above shows the relationship between characteristics and cause factor, so I have named it the cause and effect diagram. Cool. As mentioned before, the root cause and effect diagram has been also known as the Ishikawa diagram, and more recently, the fishbone diagram. When preparing a fishbone diagram, the effect of problem to be analyzed is placed on the head of the fish, and then we need to find the solution by working on the 6 branches or the 6 M's of the diagram, even though because of changes and inclusion, their names no longer start with the letter M.
Juan-Juan, what does the 6 M's in the fishbone diagram represent?
Oh, the answer is simple. This is also briefly explained in my process capability video. Check it out. The 6 M's in the fishbone diagram represent possible causes of process variation, but also represent potential root causes. Variations in the machine. Variations in the manufacturing method. Variations in personnel. variations in the measuring method, variations in the raw material, variations in the work environment.
Juan-Juan, can you give us some examples of fishbone diagrams?
Yes, indeed. This is an example from a metal stamping company that was having problems with the slug marks in the product. As you can see, for potential root causes in their method, they selected inspection method for slugs. What the company was looking for was if the personnel had the proper instructions and if they were looking for the slugs during the stamping operation. They also review if the machine was set up properly, especially on the speed or strikes per minute. Sometimes, if the presses run too fast, it is difficult to remove all of the slugs. By the way, neither of these potential causes was the root cause of the problem. For potential root causes associated with the material, the company reviewed if the thickness of the material was within a specification or not, since material out of the specification can be the root cause of many problems during the stamping, same as material hardness. Too hard or too soft material could create all kinds of problems. The material characteristics were found to be within specifications. For root causes associated with personnel, they review if personnel had the proper training, or if due to attendance issues, newer or untrained personnel was running the equipment. Personnel was found not to be the root cause of the problem. And by the way, when preparing a fishbone diagram, try not to use human error as potential root cause. Instead, look for possible flaws in the training program of the company. For work environment, the company looked into the shop lighting, especially around the inspection area. Lighting found to be appropriated. Also, they looked into possible variations of electrical power, and the power was found to be appropriated for the equipment being used. For measurement, they look into possible measurements errors. Same as before, we're not talking about human errors. We're talking about measurement errors, which I will discuss in an MSI video. They also look into visual inspection issues. I know. Visual inspection is not really a measurement, but you can put it here since it is associated with inspection. None of these was found to be the root cause of the problem. And finally, the company looked into the machine for proper maintenance and proper air pressure being supplied, and that was found to be the root cause. The air pressure in a blower used to remove the slugs from the press after stamping was found to be too low. So the air pressure was increased and that eliminated the problem. So low air pressure in the blower was the real root cause for the slug marks. This is another example made in an Excel format. By the way, the previous format was made in Visio. You can find in the internet free templates for fishbone diagrams, either in Excel, Word, Visio, and other applications. But be careful not to download a virus. You can also get a very good format directly from the American Society for Quality website. By the way, I'm a certified Six Sigma black belt and a senior member of the ASQ because I am very old. Going back to the example, the problem was that the company received customer complaints related to dirty products. Please notice that this company divided the potential root causes in two sides. In the hard side, or root causes associated to mechanical factors, and the soft side associated with human factors. They also added a continual improvement loop, since they wanted to determine if the improvements made to the process will reduce the customer complaints and increase customer satisfaction. In this case, the company found that the dirty parts were related to multiple factors, such as dirty measurement equipment, corrosion in the raw material, oil leaks on the equipment, lack of preventive maintenance, as well as lack of cleaning instructions and lack of training of the involved personnel related to proper handling. You will find that problems or conditions in manufacturing may have more than one root cause, and the fishbone diagram will help you to make the discovery. And that's it. Now, let's go to my final thoughts.
Hello, and you are?
The name is Juan-Juan.
Okay, Mr. Juan, can I offer you something to drink?
See, a margarita on the rocks, shaken, not stir, please. But before that, here are my final thoughts. Fishbone diagrams are great tools to find out the root cause of a problem or condition. But be careful. Never try to create a fishbone in the comfort of your office. No, 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 no. You need to perform a real shop floor investigation before creating the diagram. Go to the machine and watch it running. It is also a good idea to take videos so you can analyze them later. Talk with the machine operators. They know the problem inside and out, and they can offer good ideas and suggestions for improvement. Review the procedures and work instructions. Walk around the shop. Check the materials. Check the gauges being used. Review packing materials and talk to the personnel on other departments. Think of the fishbone diagram as a result of a multidisciplinary and cross-functional effort. It is until you have made all of these observations that you can start working on finding the root cause of your problem. And never work alone. Always work with a team. Well, that's it for now. See you next time. And until then, take care of yourself and each other.
Ready for your margarita, Mr. Juan?
Cool.